9.3 is on polar and rectangular forms of equations. So rectangular form is when you have an x coordinate and a y coordinate. Polar form is when you have your r theta. So again, this is unique. This has infinitely many equivalent points. To convert between the two, we're basically using the concept of a right triangle, okay? So this is my x and y distance, there's my point. So to get r, I can do x squared plus y squared equals r squared, or r equals the square root of x squared plus y squared. And then theta is inverse tangent of y over x. If we go for x is positive, which means it'd be in quadrants 1 and 4. If x is negative, you would be over here. Okay. And in which case, if you did inverse tangent of y over x, you have to add 180 to that to get either of an angle that would be in quadrant 2 or in quadrant 3. Okay. So if x is negative, that would put you over here. So additionally, x here is equal to the cosine of theta times r, because cosine of theta would be equal to x over r. So then we'd multiply by r. So x is r cosine theta and y is r sine theta. So these are the conversion factors that we're going to use. They're going to give you polar coordinates and they want you to change them to rectangular. Or they're going to give you rectangular coordinates and they want you to change them to polar. Okay? So we have -6, -120. This is in polar. We're going to change it to rectangular. So my x is equal to -6 times the cosine of -120. Well, cosine of -120, if you need to draw yourself a little picture, -120 would give me a reference angle of 60 degrees. So this is going to be a -1, 2, and a negative square root of 3. So the cosine of -120 is going to be a -1/2. And it's been a while since you've done these, so if you don't have them memorized, this is exactly what you can do. You can draw yourself a little picture. And then -6 times -1/2 is 3. So this is 3, comma. And then we want our theta, okay, or sorry, our y in place of our theta, because this is going to be the rectangular xy. So y is equal to -6 times the sine of -120. And the nice thing is if you already drew yourself a picture, you can just look at your picture. So the sine of -120 is negative square root of 3 over 2. So I have -6 times negative square root of 3 over 2. And I end up with, excuse me, 3 square roots of 3. And if you would like to quickly check your answer, you can type that in the calculator and type that in the calculator. This one obviously is going to give you a decimal approximation. Okay? All right, another. This one is in polar. We need to change it to rectangular. X equals 5 times the cosine of pi thirds. Again, if you need to, pi thirds would be here. Pi thirds is equivalent to 60 degrees, so this is 1, 2, and square root of 3. So the cosine of pi thirds is 1/2. So 5 times 1/2 is 2.5. Y equals 5 times the sine of pi thirds. And the sine of pi thirds is square root of 3 over 2. So I get 2.5 times the square root of 3. Polar, rectangular. This is in rectangular form and we need to change it to polar form. So this is the information I need to use over here. This is in quadrant 1. So this is 4, x is 4, y is 4, square roots of 3. So a squared plus b squared equals c squared, or x squared plus y squared equals r squared. So r is the square root of 4 squared plus 4 square roots of 3 squared. So this is 16 plus 48, or square root of 64, which is 8. And then my theta, it's in quadrant 1. You may recognize this is a 30, 60, 90 triangle. So this actually would be a 60-degree angle. If they don't specify in degrees or radians, you can do it either way. So this could be 60 degrees or pi thirds. Okay, and if you need to, if you didn't recognize it, theta is the inverse tangent of 4 square roots of 3 over 3, excuse me, over 4. So I need to I'm going to put this in degree mode and then do the inverse tangent of 4 square roots of 3 over 4. And there's my 60 degrees. Last one, negative 9, 4. Negative 9, 4 puts you in quadrant 2. This is not a special triangle. This is not a 30, 60, 90. This is not a 45, 45, 90. This, we're going to have to use the calculator. So r equals the square root of 4 squared plus negative 9 squared, or 16 plus 81, square root of 97. 97 has no perfect square factors, so nothing else I can need to do with that. And then theta, this is where x is negative, so I have to do the inverse tangent of y over x plus 180, okay, because it's in quadrant 2. So the inverse tangent of negative 4/9 and then plus 180. Ooh, I did times 180, gosh darn it. There we go, 156 degrees. And I think on most of these, they're having you round to the nearest hundredth, okay? So for this one, I've got my R value is exactly square root of 97. If you needed to check your answer, obviously you can go in the back of the book. And then this one, you've got 156.04 degrees.